I'm Howie, and I run machine learning and AI at Zscaler. Ken and then Steve gave me a very good view about the jobs for CISOs. The analogy of you're moving the cheese, and then Steve's about the job is about being a storyteller. That's very interesting. Let me see. All of the above, yes. So that's a little bit tricky question, but yes, all of the above. So it's not as tricky as I thought. So let me just go to my next. So it is about all of the above, right? Because I have a fantastic team. Lots of them have PhDs. They know data science inside out. But my team also work with our domain experts across the company, from the security research people, the experts, as well as the product people who actually know how to productize it with line rate, with 100 within the 150 data centers, policy-driven, dynamic. So we actually work among each other very closely. There is a saying called "it takes two to tango." It's actually taking three to tango. One more thing is actually the data. In Ken and then Steve's talk, they actually talk about the data, right? The massive amount of the data we have. Ken mentioned we have a few more than a few customers. Yes. When you have 25% of the global 2,000 companies data, the transaction going through, we actually have a pretty good view about what's going on. If a file, if a domain is only being accessed by one user of one company, it's very, very different when it's being accessed by a gazillion number of people among thousands of people, so thousands of companies, as an example. Now, the question is why AI at the first place? That's kind of because we are talking about security here, right? And I really like the analogy that Ken mentioned about you need a glass of wine when you move the cheese, because if you just move the cheese alone, it's actually hard for people to accept. Why is that? Because a lot of times security is about compromising the user experience, because you limit people or you put additional constraints. In this session, I'm going to talk about how AI is actually going to make the user experience good at the same time having high, potentially better security, right? So that's kind of where AI can come into the picture. Now, it's actually more than that. It's actually about security landscape is changing. Like Brad said, we as an industry have been doing pretty well for the known bad. What about the unknown bad, right? And security industry has matured quite a bit in the last 20, 30 years. I would say that we know a lot better or more about when something is known bad, how to do that fast, accurate, right? And then process it and respond to that. But when something is unknown, do we have a very good idea? I think as industry, we are learning. But that's where AI is coming into the picture. The AI is trying to predict the unknown bad. So what kind of unknown bad out there? It can be anything and everything. But just to give you some examples here. The one example, a few examples, malware. I think we just early on, we talked about the ransomware. Ransomware, you can say that's a flavor of the malware, if you will, from technical point of view. So how do we block unknown ransomware, right? The known ransomware, the known malware, we know it. There is a signature. Zscaler has 175,000 signatures, new updates a day. Most of them are the security signatures. But what if, those are things that's yet to be seen, yet to be born, but we want to predict that. We need to leverage AI machine learning to predict those things. So another example would be domains, right? Because people may want to from the inside and then leak data out to a particular IP address, to a particular domain, or download some bad stuff from the malicious domains. How do we know this domain is bad? If it's known, then yeah, we would block it. But this site or this IP address was just set up a minute ago. There's no signature for that. How can machine learning will be able to detect and then block that? right? That's another example. And then early on, people also said one of the biggest threats is human ourselves, right? It can be, people can be can evolve even, right? Because you can have a good employees for 3 years, but tomorrow this person become disgruntled or whatnot, and then start doing bad things. So what can you do? One static policy is not going to cut it because things are evolving. How can you react to the very fast changing landscape? So that's what AI is about. So here I'm going to give you 3 concrete examples about how we are leveraging AI. One is actually still the file-based malware, as I mentioned. There are literally 1 million new malwares a day. Most of the 99 point some percentage of them is actually the variations of the known malware, but they are still brand new malware without signatures potentially. So how can you block it? Zscaler actually has a lot of innovation to deal with this problem for many years. We have cloud sandbox, we have a quarantine functionality for years. Because of our architecture, the inline proxy architecture, we are able to do inline sandbox quarantine. However, there's one challenge people often tell us, right? Hey, ideally I want to quarantine each and every file, but I cannot afford to it. Why is that? Because I don't want each user to wait for 2 or 3 or 4 minutes for each file download, because that's going to kill it, right? It's this Ken's example that, when you move the cheese, you need to give a glass of wine. Here, we actually want to give you a glass of wine. By that, we want to give you the capability of quarantine. At the same time, we give you almost instantaneous speed. How do we do that? This is where AI comes into the picture. So we have an AI model. This is actually, we released last year. I have a blog on it. If you wanted to know more details, there is more data in it. But the high level idea is about, we have a pre-filtering AI model to tell, hey, is this file worthy quarantine or not? If it's worthy quarantine, we send the file to the sandbox, wait until the result come back, and then let the file go through. Otherwise, we say, hey, this is a pretty benign. There's no reason to wait. I'll let you go. And of course, sandbox will still get a result for you, but you don't really need to wait. If you can have a model, AI model, that really majority of the file goes through, because majority of the files are benign on the planet. That's still true, despite 1 million new malware a day. Still way more benign files out there every day passing through our network. If you allow most of the files to be benign and go through instantaneously, then you get a better of the both, right? You have the quarantine, but then you also have the usability. So this is actually what we exactly did. We did a pre-filtering AI model, and then the job is to do file quarantine. The result is actually quite impressive. This is actually a study we did with a Fortune 500 companies together. This is the data from 2 years ago. I think our model is even better today. In that particular study, there are 5,700 files going through their network, and then we actually, the AI model says actually 5,200 of them, you can go through it instantaneously. Basically, this is called instantaneous quarantine, right? Or we call it a smart quarantine. So this is how we actually achieve quarantine and the speed at the same time. What's the net? The net is when you tell people, hey, I want to quarantine, you are not going to have people rebel. People are going to say, no, don't move my cheese, right? Here, we actually still make sure that the majority of your user experience is actually as good as a line rate. And only for small single percentage of the file, we actually hold the file and then we do the quarantine. Again, like I said, this is the study we did 2 years ago. This is even better now. So you almost don't even notice any user impact. So that's kind of where AI comes into the picture, right? Doing this kind of instantaneous classification so that combining that with the quarantine cloud sandbox innovation we have had for years. And altogether, we actually deliver customer the very new experience with a heightened security. Now, this is just a file-based, right? And I also mentioned it could be a domain, right? So I can reach out to a domain, leaking information or downloading something. How do I know that this domain is actually right or not, right? here's the thing. There's a bad news. The bad news is there are so many new domains every single day. How are you going to block it, right? Because a lot of time when you really wanted to know, is this good or bad, you have to do so much correlation because, you don't just look at, hey, someone going to this domain or IP address. You wanted to see who else went to that domain. You wanted to see what did the user do before that, after that. You can imagine this is a very, very comprehensive study, right? You're talking about millions and then millions and millions of the new domains every day. You cannot afford to do that line rate, right? So here's another innovations we are working on. And then we did a pre-filtering domain reputation model. And this is something that we actually are pretty proud. So I show you the lab study we got pretty recently. This is actually, we just got, so many, random domains into this AI model. And only a small percentage, as you can see, we actually have a threshold. On the left-hand side, we think this is suspicious. The name of the game is, if all the suspicious, all of the potential bad stuff fall into that on the left, then that's a success. That means that we don't need to do deep analysis on all of the new domains, right? Because processing each new domain is very expensive. So here's something we did. We actually did a test, a bunch of test cases, and all the 12 SolarWinds breach domain test cases passing through this AI model gets pre-filtered successfully, meaning that we think this is suspicious. It's worthy deep analysis. So this is actually a winning for the AI model because we do the pre-filtering successfully. But that's just step number one. There is a step number two. Once we have a much smaller set, then we use another AI model to actually do the unknown botnet detection, right? We look at the domain name, right? We do some lexical analysis. We see, is that a name scoring, typo scoring? We see how this domain is being referred dynamically, statically, what's the access sequence? And I can mention that we actually have access to more than a few customers' data that would tell us that, hey, what's this domain popularity? Is that just a one user or one customer going to that domain, or 500 or 5,000 customers have users going to that domain, right? That gives us a lot of clue what's going on. And then there is a usual ASM who is kind of the reputation. With that, this is just an example, concrete example we got. Sometime in February, we used this 2 steps process. We identified, hey, this is unknown threat, and then we actually started blocking it. Now, of course, once we know it, this becomes a known threat, right? But otherwise, this is an unknown threat. So basically, the game is about, there are so many things that's unknown, but how can we find a known thing? AI is actually helping to find it out by looking at so much data and then process it and then develop the model so that we can make the threats, the unknown threats surface. The last example I want to give is about human, right? So human can be a threat. It can be a disgruntled employee or compromised the user or whatnot. In this particular example, it's pretty obvious, right? If a user logging to US, to New York or from Bangalore, India, back and forth a few times. Not always a impossible travel, not always a malicious behavior, but it's kind of suspicious, right? Because how is that possible that this user is going to log in from different locations within just a few minutes, unless there is some setup, right? Now, conceptually, this is super easy to talk about it. I think Ken also mentioned the UEBA thing in his panel talk. But when you double click, it's actually super difficult. Why it's super difficult? Because some people, they may use VPN. Some people, they are engineers. They log on to different systems. Some people actually do this kind of the things, have different kind of behavior all the time. But some other people, they never have this need and then they never done this, but suddenly it appears. So what I mean is actually very contextual, right? It's a very dynamic thing. You cannot have just one policy. Hey, in this company, if I ever see a login from 2 different locations within 24 hours or within 1 hour, I view that as impossible travel and just block it. There are probably way more false positives or way more incorrect false alarms than you can handle. It's a very, very contextual. So that's where the machine learning comes into the picture. Machine learning is very good at picking lots of signals and having personalized alert in this case. Why personalized? Because a strange behavior, a kind of a strange behavior may be strange to me, but maybe not strange to Brad, right? Because that's Brad's job to do certain behavior all day long. But for me, I don't do that kind of thing. When I start doing that, it's different. So this is actually quite interesting to us. It's not a one size fits all. And then that's where AI machine learning comes into the picture. So in summary, here's the thing. We are actually blocking the unknown threats via the AI, the big data, the networking effect that Ken is talking about. The pre-filtering option that I give you two examples of file-based, right? The domain-based, the domain-based attack. So how do you do the pre-filtering? And then last but not least, it's the complex rules, right? Just like for consumers, your Google News is different from my Google News. Here we are talking about the threshold to trigger the alarm is yours is different from mine. You have your security policies, I have my security policies. They are only possible because of the AI and then the data we have. So